Hey everyone, and welcome back to LearnFlow. We're starting today with a clear acknowledgement. The entire global landscape has been fundamentally reshaped. Look around at your news feed, at the productivity tools your company relies on, at the generative art winning major contests, or at the latest breakthrough in medical diagnostics. AI is absolutely, unequivocally everywhere. It's generating art, it's writing code that builds sophisticated applications, it's creating video content, and it's engaging with us through our phones. The feeling we all share is that the entire world is accelerating at an unprecedented rate, and AI is not just the engine driving this profound transformation. It's the GPS, the primary driver, and often the backseat critic offering suggestions. And if you're sitting there thinking, I need to grasp this, I need to acquire this skill, but where on earth do I even begin to grab hold of this constantly moving, massive technological wave? Then this is the definitive, long-form, step-by-step video for you. I know. The term artificial intelligence sounds fundamentally intimidating. It conjures images of complex mathematical equations and algorithms reserved only for the geniuses with PhDs in computer science. But I'm here on LearnFlow to tell you that the fundamental core concepts of how AI learns are not just understandable. They are built upon the very same learning logic that we, as humans, employ every single day of our lives. We're going to strip away the intimidating jargon, the neural nets, the backpropagation, and the stochastic gradient descent, and get down to the simple foundational ideas that are powering the modern world and the future economy. For the next 30 to 40 deliberate minutes, we are going to dive deep into AI learning specifically for the absolute beginner. We'll cover the basic mechanics of how machines learn, but we are also going to anchor all of this technical learning to a single, essential philosophical truth that will guide your entire journey. The critical role of human judgment in the age of automation. Understanding the technology and the code is only half the battle. The other, more crucial half is understanding the necessary human responsibility, the ethical compass, the judgment that must guide this unprecedented power. This, ultimately, is the difference between being a passive user of powerful tools and becoming a true master, architect, and ethical guardian of the technology. So please take a deep breath, settle in, grab your notebook, and let's begin the process of demystifying AI together, focusing not just on the code, but on the complexity and the challenging future ahead. The very first foundational step is to define our terms clearly. What is artificial intelligence? In the simplest, most accessible terms, AI is about building computer systems that can execute tasks that traditionally and historically require human cognitive abilities. This encompasses the ability to learn from historical experience, the ability to recognize incredibly subtle and complex patterns hidden within vast amounts of data, and the ability to make informed, nuanced decisions with a high degree of autonomy. It's about teaching a machine to think and reason, not just to meticulously follow explicit instructions written by a programmer. Now, we must establish a key distinction. If AI is the whole vast, overarching field, the grand dream of a truly thinking, reasoning machine, then the practical engine that powers nearly all of the successful functional AI you interact with today is a crucial subfield called machine learning, or ML. This distinction is absolutely paramount for a beginner. Let's return to my cooking analogy, but let's make it more illustrative. Traditional programming is like following a recipe exactly. A programmer writes down every single step. If the value is X, perform action Y. Otherwise, perform action Z. The computer only knows what you explicitly wrote. Machine learning is fundamentally and radically different. It's like teaching a computer to become a master chef by simply showing it millions of pictures of delicious dishes and saying, "Look at these examples." Instead of writing rigid, logical rules for pancakes, you show the computer 1,000 different pancakes, waffles, and crepes, and you repeatedly tell it, "This one is a pancake." The machine then, through statistical analysis, figures out its own internal proprietary rules for what constitutes a pancake, the pattern of roundness, the specific texture, the color gradient, and can then accurately identify a new pancake it has never encountered before. It learns from exposure to data, not from rigid, explicit lines of code. This ability to learn patterns from sheer statistical exposure is the core revolutionary idea that has propelled computing forward. The theme introduction, this very notion of learning from data, is precisely where our theme, the critical role of human judgment, finds its profound foundation. Why? Because the AI is only and absolutely as robust as the data we give it and the initial ethical parameters we set for it. If the data is messy, incomplete, or fundamentally biased against certain groups, the AI will not only fail, but it will amplify and perpetuate that unfairness across millions of decisions. Therefore, our human judgment is required at every crucial junction. In the initial choice and cleaning of data, in the careful setting of ethical guardrails, and most importantly, in constantly auditing and correcting the AI when it inevitably deviates or makes a dangerous error. This, my friends, is not a technical problem. It is a profound ethical responsibility. Since machines do not learn through the organic process of reading or going to a school lecture, they learn through three main, distinct mathematical methodologies. Understanding these three specific approaches is the absolute key to understanding all of modern AI. These are supervised, unsupervised, and reinforcement learning. First, supervised learning. This is the most common and easiest type for a beginner to grasp because it involves a teacher who meticulously grades the machine's work. The data is pre-processed and carefully labeled. For example, if we are training an AI to recognize images of a specific rare bird, we feed it 10,000 pictures, and for every picture, we attach a label that explicitly says rare bird or common sparrow. The AI keeps making tiny mathematical adjustments until its predictions are accurate. The theme focus here is on the judgment check in labeling. Human judgment is critical in the initial labeling process. Imagine if you are building an AI for medical diagnosis and your team mislabels 10% of the malignant tumors as benign. The AI will build a fatally flawed, optimistic definition of cancer, leading to catastrophic real-world errors. We have to apply rigorous human judgment to ensure the training data is clean, unbiased, and complete before the machine ever sees it. Next, we move to unsupervised learning. Here, the core characteristic is that the AI has no teacher. It must act as an independent detective. The data is given to the system raw. It is completely unlabeled. We give the AI a massive dataset, say 1 million customer records, and simply tell it, find patterns. Group things that look similar. The AI identifies hidden statistical commonalities and sorts them into groups. This process is used extensively in recommendation systems. The theme focus here is on the interpretation check. The machine can only say, these 50,000 customers have similar buying habits. It is the human marketing or strategy analyst who has to apply judgment and strategic insight to say, okay, that group is young urban professionals interested in sustainable products. Here is the strategic meaning, and here is how we should allocate resources. The machine finds the pattern. The human applies the meaning, strategy, and ethical implementation. Finally, we have reinforcement learning, RL. This is the most complex type and is crucial for things that involve real-time sequential action, like robotics or autonomous vehicles. The simple idea: the AI learns through massive trial and error, getting explicit rewards and punishments. The AI is an agent operating within an environment. It performs an action, and if that action helps it reach a defined goal, it gets a significant reward. Over millions of trials, the AI learns the optimal sequence of actions. The theme focus here is on the ethical reward check. This is philosophically the most critical area. If you are training a large language model to behave, how do you set the reward? Is the reward maximizing truthfulness? Or is it maximizing engagement and sensationalism? The reward function dictates the AI's morality. Our highest ethical judgment must be perfectly coded into the reward system. Otherwise, the resulting machine behavior will be optimized for a goal we never truly intended, which could be anything from crashing a car to manipulating a user. Now, let's talk about the underlying technology that has made all of this possible today: deep learning. This is a subset of machine learning that uses incredibly sophisticated mathematical structures called artificial neural networks. These are not just one layer. They have many layers of interconnected nodes, inspired by the human brain. This deep layering is why our technology is so powerful in computer vision and natural language processing, NLP. However, these deep networks create the notorious black box problem. The network knows the answer, but the human programmers can't explain exactly the thousands of internal decisions it made to reach that specific conclusion. This opacity is a direct threat to regulatory compliance and accountability, and it highlights why the continued role of human judgment to audit and validate the AI's results is absolutely non-negotiable. Let's look forward, because this is where the AI field becomes not just exciting, but fundamentally transformative for society. First, we are seeing the rise of multimodal AI. The future is a single AI that can seamlessly understand and generate text, images, video, and audio at the same time. This vastly expands the creative potential of AI, turning simple text prompts into fully produced multimedia content. This shift is revolutionizing content creation for platforms like LearnFlow and is changing how we communicate. Second, let's discuss the path to AGI, artificial general intelligence. Right now, we operate primarily with narrow AI. AGI is the dream of building a machine that can perform any intellectual task that a human can: true reasoning, creativity, and abstract thinking. While experts still argue about the timeline, powerful models continue to show expert-level cognition in more and more domains. When AGI arrives, the pace of change will become exponential and unpredictable, making the conversation about human judgment the most vital one we will ever have. Third, we have Edge AI and TinyML. Not all powerful AI will reside in giant, cloud-based data centers. Edge AI means running complex models directly on your device, your phone, your camera, your watch, without connecting to the cloud. TinyML takes this further, putting AI on tiny, low-power microcontrollers. This is crucial for privacy, data stays local, and real-time reactions. No network lag. This is where AI becomes truly ubiquitous, invisible everywhere, and always on, touching every aspect of our physical world. Now, let's summarize the immense potential and the necessary caution that must guide every beginner. The pros are massive: automation of tedium, uncovering hidden insights, and radical personalization. The cons are a profound responsibility. We must actively fight bias and fairness in the data. We must wisely manage the job shift through policy and education, and we must demand transparency from the black box. The beginner's action plan is simple, direct, and actionable. 1. Master Python. It is the language of AI. 2. Build your math foundation. Focus on linear algebra, calculus, and statistics. 3. Start with simple projects and libraries. Use scikit-learn or PyTorch and build something small and interesting. 4. Embrace the community. Use platforms like Kaggle. Thank you so much for joining me on this extensive, deep dive into AI learning for beginners here on LearnFlow. What I hope you take away today is that AI is a series of powerful, learnable mathematical techniques. But the future of this world-changing technology does not rely solely on the code. It relies on us. The true challenge ahead is not teaching the machine to be smarter. It's teaching ourselves how to effectively apply our ethical and moral judgment to guide and govern its immense power. The age of AI is truly the age of human judgment under pressure. Now, I want to hear from you, thinking about the future. Which of these three trends, multimodal AI, AGI, or TinyML, do you think will be the most ethically challenging for human society, and why? Let me know in the comments below. If this extensive, long-form breakdown helped demystify AI for you, please hit that like button, subscribe to LearnFlow so you don't miss our next deep dive, and ring that bell. Until next time, keep learning and keep asking the big questions. I'll see you in the next one.